Welcome, dear students. The topic for today's discussion is periodic trends and chemical reactivity. My dear students, mainly there are two types of the elements which are found in the periodic table. One are the metals, 78% of the periodic table, and other are the non-metals. While there are some semi-metals or metalloids, but they are only 7 out of 118 elements. So whenever we are talking about the reactivity, then we talk about the reactivity of metals and non-metals in the periodic table, and we talk about the trends of the reactivities of metals and non-metals in the periodic table. First of all, you need to know that reactivity of metals is basically dependent on their ionization energies, and there is inverse relation between the reactivity of metals and ionization energy. Means greater the ionization energy, lesser will be the reactivity of metals, and vice versa. The metals are basically electropositive elements that have high tendency to lose electron and form the positive ions. So if a metal has low ionization energy, it means to remove the electron from the atoms of that metal will be easier, and it will be easier to form its cations, so it will show high reactivity. And if a metal has high ionization energy, it means it has low tendency to lose the electron and form the cation, so its reactivity will be lesser. Now, my dear students, when the metals they lose electron and they form positive ion, it means they are self-oxidized. Mean after losing electron, they are self-oxidized and they will reduce the other chemical species reacting with them. So that's why we say that all metals are self-oxidizing, but they are reducing agents. Stronger the metal, stronger will be its reducing property, more will be its reducing property. So if a metal has low ionization energy, it will be highly reactive and it will act as a very strong reducing agent. On the other hand, the reactivity of non-metals that is related to the electron gain enthalpy, which is also called as the electron affinity. And the reactivity of metals is directly related to electron affinity or electron gain enthalpy. So greater the electron gain enthalpy or electron affinity, more will be the reactivity of the non-metals. And my dear students, the non-metals are those elements that have tendency to gain electron and form negative ion. So when a non-metal gains electron, it is self-reduced and it will oxidize the others. So all the non-metals, they are basically the oxidizing agents. Higher the electron gain enthalpy, more will be the reactivity of non-metal and stronger will be the oxidizing property of that non-metal. Now, my dear students, when you move from top to bottom in a group, atomic radius increases and ionization energy decreases. When ionization energy will decrease, then the reactivity of metal will increase. That's why when we move in the group of the alkali metals from lithium to francium, then the ionization energy of lithium in the group is highest and that of cesium or francium is lowest. So lithium will be the weakest reducing agent and weakest metal among alkali metals, and francium and cesium, because of their very low ionization energy, they will be the strongest metals with maximum metallic character and reducing power. And similarly, when you will move from left to right in the group, the atomic radius decreases and the ionization energy increases. When the ionization energy increases, then the reactivity and reducing power of the metals that keeps on decreasing. So you will see the strongest metals on the extreme left of the periodic table, the weak metals on the middle of the periodic table, and the weakest metals on the right side of the periodic table. My dear students, uh, at the left of the periodic table, there are S block elements, group 1A, alkali metals, and group 2A, alkaline earth metals. These are the elements that have lowest ionization energies and they have high reactivity. They have maximum electropositivity. They are very reactive metals. Then, when we move towards the right, there are transition elements, D block elements and F block elements, outer and inner transition elements. They are moderately electropositive they have slightly high ionization energies as compared to the group 1A and 2A, so they are less reactive as compared to the alkali and alkaline earth metals. They are very strong reducers. They are relatively weak reducers as compared to the S block elements, alkali metals and alkaline earth metals. And then on the extreme right, there is P block from group 3A to 7A. We are not talking about noble gases as they are chemically inert. So from 3A to 7A, most of the elements, they are non-metals with high ionization energy and high electron gain enthalpy, electron affinity. At the extreme right of the periodic table, you will find the halogens, which are the most reactive non-metals. So my dear students, the reactivity is maximum at extreme left and extreme right of the periodic table. At the left, there are highly reactive metals in the form of alkali metals and alkaline earth metals, and at the right, there are highly reactive non-metals in the form of the halogens. While the middle portion of the periodic table, that consists of the transition elements, they are reactive but less than extremes of the periodic table. So they are moderately reactive elements actually. Now, my dear students, the reactivity of an element is judged by its reaction with the oxygen. When the elements of alkali metals and alkaline earth metal group, they react with the oxygen, they form the basic oxides, just like the oxides of sodium, that is basic oxide. When it is dissolved in water, it forms caustic soda, which is a very strong base. The transition elements, they form amphoteric oxides, just like the zinc oxide. Zinc oxide is amphoteric in nature. It reacts with both acids and bases. And when we talk about the p block elements, especially the halogens, which are the strongest non-metals, then they form acidic oxide, just like the Cl2O7. And when the Na2O that will react with water, obviously it will form a very strong base in the form of NaOH. Amphoteric oxides, keep this thing in your mind, they do not show any reaction with water because water itself is amphoteric. And Cl2O7, when it is dissolved in water, it will form perchloric acid, which is the strongest inorganic acid. And my dear students, the oxides which are basic in nature, they react with water and acids. The oxides which are acidic in nature, they react with the water and bases. And the amphoteric oxides, they react with both acids and bases, but they do not react with the water. So this one is about the trend. It means is shifted from basic to amphoteric to acidic. Extreme left basic, middle amphoteric, and on the right side you will see both amphoteric and acidic oxides. So moving from left to right, the trend is shifted from basic to acidic oxides. And similarly, in case of non-metals, when you move down the group, obviously the electron affinity decreases. General trend is that electron affinity decreases and the reactivity of non-metal also decreases. So fluorine is among the strongest and most reactive non-metals with maximum oxidizing power, while the iodine, which is at the bottom of the group of the halogens, that has least non-metallic character, it has least reactivity among the halogens, and it has weakest oxidizing power. Similarly, when you move from left to right in a period, the electron affinity keeps on increasing, its negative value keeps on increasing. So there are the strongest metals, the strongest non-metals, they are found at the right corner of the periodic table. So you will find the strongest non-metals on the right corner of the periodic table. This was about the trends of the reactivities, that maximum reactivities are found on extremes. The middle portion that shows moderate reactivity, they are not as much reactive metals as compared to the elements on the extremes of the periodic table. So this was a slight discussion about the reactivity of the metals and non-metals.